cutoff frequency and work function. The photoelectric effect is observed in certain metals, when light of a particular frequency is shone on the surface of the metal. Here, a sheet of zinc metal emits photoelectrons when ultraviolet light is shone on it. If the frequency of light that is shone on the zinc metal is reduced to green light, the phenomenon is not observed. Therefore, a certain minimum frequency of radiation is needed, called the cutoff frequency, for the photoelectric effect to be observed. The cutoff frequency is denoted by F0. The photoelectric effect cuts off below this frequency. This minimum frequency is specific for each metal. For example, sodium metal has its cutoff frequency in the visible part of the electromagnetic spectrum, green, whereas zinc metal has its cutoff frequency in the ultraviolet part of the electromagnetic spectrum. We know that the frequency and wavelength of electromagnetic radiation are related by the speed of the electromagnetic radiation. C equals F lambda, where c is the speed of light in a vacuum. F is the frequency of electromagnetic radiation in Hertz. Lambda is the wavelength of electromagnetic radiation in meter. The equation can be rearranged as lambda equals c over F. If we consider electromagnetic radiation that has the same frequency as the cutoff frequency of the metal F0, we get lambda max equals c over F0. The minimum frequency at which photoelectric effect is observed, F0, corresponds to wavelength lambda max. This is the maximum wavelength at which photoelectrons are ejected from the surface of the metal. Note that the speed of electromagnetic radiation is constant. The minimum energy of radiation needed for ejecting an electron from the surface of a metal is called the work function of the metal. It is denoted by W0. We know that the energy of a photon is related to its frequency by the equation E equals hf, where E is the energy of photon, h is Planck's constant, f is the frequency of the electromagnetic radiation. If we consider electromagnetic radiation that has the same frequency as the cutoff frequency of the metal F0, we get W0 equals HF0. If a photon of light that is shone on the surface of a metal has an energy that is greater than the work function, the photoelectric effect is observed and photoelectrons are ejected from the surface of the metal. If not, no photoelectrons are ejected and the effect is not observed. The work function is material specific. We have discussed about photoelectric effects in metals, but the effect can be seen in other elements too.
Starting to feel it? Now go master it with